Ever hit that awkward moment where your middleware needs to handle both MCP sessions and raw HTTP requests, but you're not sure which context you're actually running in? You'll see exactly how to build session-aware middleware that gracefully adapts, checking for MCP session availability first, then falling back to HTTP helpers when needed, all while keeping your request pipeline clean and predictable.
From FastMCP server middleware, import middleware, middleware context. Class session-aware middleware. Async def on request, self context, middleware context, call next. CTX equals context, FastMCP context. If CTX, request context. #MCP session available, can access session-specific attributes. SessionID equals CTX, session ID. Requested equals CTX, request ID. LC. #MCP session not available, yet use HTTP helpers for request data. If using HTTP transport. From FastMCP server dependencies, import get HTTP headers. Headers equals get HTTP headers. #access HTTP data for auth, logging, etc. Return await call next, context.
This demonstrates the middleware pipeline pattern for cross-cutting concerns in RPC systems. The code shows session-aware middleware that intercepts requests before they reach handlers, allowing you to inject logic like authentication, logging, or request transformation without modifying core business logic. What makes this distinctive is its ability to operate at the protocol level while remaining transport-agnostic, working equally well with HTTP, SDDIO, or other transports. The pattern works by creating a chain of responsibility where each middleware component can inspect, modify, or short-circuit requests before delegating to the next layer. The context object provides a consistent interface to request metadata regardless of transport, while the callNext function maintains the pipeline flow. This separation of concerns lets you compose orthogonal features like metrics collection, rate limiting, and session management independently of your core tools and resources. This approach solves the problem of scattered cross-cutting logic in RPC servers. Instead of embedding authentication checks in every tool or manually instrumenting each endpoint, you centralize these concerns in reusable middleware components. The pattern shines in multi-tenant systems, API gateways, or anywhere you need to apply consistent policies across diverse operations while keeping your business logic clean and focused. Let's break it down.
From FastMCP server middleware, import middleware context.
Imports the base, middleware, class, and its context type from FastMCP's server framework. These provide the interface for intercepting requests and the strongly typed context object that carries request metadata through the middleware chain.
Class session-aware middleware. Async def on request, self context, middleware context, call next. CTX equals context, FastMCP context.
This defines a middleware class that hooks into FastMCP's request pipeline. The onRequest method intercepts every incoming request, and extracting FastMCP context gives access to session metadata or HTTP headers depending on the transport layer. This is the standard middleware pattern for cross-cutting concerns like auth or logging.
If CTX, request context. SessionID equals CTX, session ID.
This checks for an active MCP session context, which indicates the request is part of an established FastMCP session. When available, it extracts the SessionID for tracking or authentication purposes, enabling session-specific logic like stateful operations or user-specific data handling.
From FastMCP server dependencies, import get HTTP headers. Headers equals get HTTP headers. #access HTTP data for auth, logging, etc.
This dynamically imports HTTP headers when no MCP session exists, providing fallback request data for authentication or logging. Critical for HTTP transport scenarios where session context isn't yet established. The lazy import pattern avoids circular dependencies while keeping the middleware lightweight.
Return await call next context.
This invokes the next middleware in the chain, passing the modified context. Middleware pattern: each layer processes the request, then delegates to the next via call next, enabling composable request handling. Without this, the pipeline would terminate prematurely. Session context awareness. This pattern demonstrates FastMCP's dual-mode session handling, where the same middleware gracefully adapts between MCP session contexts and raw HTTP transports without conditional branching in the core logic. The sessioned and requested are only available when request context exists, making their presence a runtime contract rather than a compile time guarantee. Always check request context availability before accessing session-specific attributes to avoid non-reference errors.
The context that knows everything must first admit it knows nothing.